Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 10.5, Problem 2. This is Section 10.5, it's problem number 2. It says, write each logarithmic equation in exponential form, and there's 8 equations written with logs that they want you to convert to just a regular equation with an exponent, base and an exponent. So it goes parts A through H for the eight parts. The first one, part A, says write log base 2 of 32 equals 5 in exponential form. So in its log form, I use the name Benny. I write Benny underneath the log version. The B is for base, the N is for number, the E is for exponent. So in this particular problem, the base is 2, the number is 32, and the exponent is 5. So over next to it, I'll write Ben. That's the exponential form. So you write the base first. The base is 2. Then you write the exponent next. The exponent is 5. Then you write equals, and then the number comes last. The number is 32. So writing log base 2 of 32 equals 5 is the same as writing 2 to the 5th power equals 32. Now next is part B, same type of problem. It says write log base 3 of 81 equals 4 in its exponential form. So underneath log base 3 of 81 equals 4, I'm going to write Benny, base number exponent. So again, the base is the 3, the number is the 81, and the exponent is the 4. And next to it, I will write Ben, B-E-N. So first is the base, so the base is 3. Then the exponent is next, the exponent is 4. Then we write equals, and then the number, and the number is 81. So log base 3 of 81 equals 4 is the same as writing 3 to the 4th power equals 81. The next one, part C, says write log base 4 of 1024 equals 5 in its exponential form. So underneath log base 4 of 1024 equals 5, I will write Benny, B-N-E for base number exponent. So to write it as an exponential equation, I will write Ben, B-E-N, base exponent number. So we start with the base is 4. Then next comes the exponent is 5. Then equals, and then the number. The number is 1024. So the equation log base 4 of 1024 equals 5 is the same as writing 4 to the 5th power equals 1024. And then part D, it says write log base 7 of 147 equals 3 in its exponential form. So underneath log base 7 of 147 equals 3, again, I write Benny, B-N-E for base number exponent. The base is 7, the number is 147, and the exponent is E. And next to it, I write Ben, B-E-N for base exponent number. So we start with the base is 7. Then we write the exponent is 3. Then we put equals, and then we put the number is 147. So writing log base 7 of 147 equals 3 is equivalent to writing 7 to the 3rd power equals 147. So the next part is part E. It says ln for natural log of 1 over e equals -1. Now this one seems kind of confusing, and there is no base. Well, there's a base that is implied. ln for natural log is really log base e. So what we have here is log base e of 1 over e equals -1. So we want to convert that to its exponential form. So underneath log base e of 1 over e equals -1, I'm going to put Benny, B-N-E for base number exponent. The base is e. The number is 1 over e, and the exponent is -1. And again, remember, e is that number from natural science. E is 2.718, and it goes on and on and on. It just shows up often enough in natural science. It gets its own symbol, like pi does in geometry. Pi is 3.14, and it also goes on and on and on. So like geometry and natural science, this symbol comes up frequently. So I'm going to change that B-N-E from the log form to B-E-N, Ben, for the exponential form. So the base was E. Then we put the exponent. The exponent was -1. Then we write equals, and then the number is 1 over e. So in the end, the natural log of 1 over e equals -1 can be written in exponential form as e to the -1 power equals 1 over e. And next, part F, it says write log base 2 of 1/8 equals -3 in its exponential form. So beneath log base 2 of 1/8 equals -3, again, I will write Benny for base number exponent, BNE. The base is 2, the number is 1/8, and the exponent is -3. Don't lose track of the negative. So next to that, I will write Ben, B-E-N for base exponent number. So we start with the base, which is 2. Then next is the exponent. The exponent is -3. Then I put equals, and then the number, and the number is 1/8. So by saying log base 2 of 1/8 equals -3 is the same as saying 2 to the -3 power equals 1/8. And the next one, part G, log of 100,000 equals 5. Now this one seems like I forgot to write the base, but I did not. Log without a base written is called common log, and it's implied that it's log base 10. So instead of just saying log of 100,000, it's really a little bit of an abbreviation for saying log base 10 of 100,000. Again, when the base is not written, it's assumed to be 10, and it's called common log. So we want to write log base 10 of 100,000 equals 5 in its exponential form. So underneath log base 10 of 100,000 equals 5, I will again write Benny, B-N-E for base number exponent. The base is 10, the number is 100,000, and the exponent's 5. And off to the side, I'm going to write Ben, B-E-N for base exponent number. So first I write the base. Looking back to the problem, the base is 10. Then the exponent is 5, then equals, and then the number. The number is 100,000. So saying log of 100,000 equals 5 is the same as saying 10 to the 5th power equals 100,000. And finally, the last one, part H. H says log of 0.001 equals -3, and they want you to write that in its exponential form. So like the previous part, part G, it seems like the base on the log is missing, but it's not really. If it's not written, it's assumed to be 10. Again, that's called common log. So really what they're asking you to do is write log base 10 of 0.001 equals -3 in its exponential form. The base really is in there, even if it's not written. So underneath log base 10 of 0.001 equals -3, again, I will write Benny, B-N-E for base number exponent. And next to it, I will write Ben, B-E-N for base exponent number. So first we write the base is 10. Then we write the exponent is -3. Then we put equals, and then the number. The number is 0.001. So when we're done, writing log of 0.001 equals -3 is the same as saying 10 to the -3rd power equals 0.001.